You know when you're on a video call and the person on the other side of the planet is perfectly clear? It seems like straight up magic, right? But it's actually a series of incredible solutions to some really, really tough problems. So how in the world does all that information get from out there in the world onto your screen in the blink of an eye? Well, today we're going to pull back the curtain on that unseen global highway your data travels every single day. We're going to look at the engineering marvels that conquered distance, noise, and all sorts of interference just to make our connected world possible. You ready for this? Let's dive in.
Okay, so the first and most basic challenge of any kind of communication is just getting a message from point A to point B. It doesn't matter if it's a smoke signal or a text message, you've got to find a way to bridge that physical gap. And it turns out pretty much every communication system ever invented follows the same 5-step blueprint. First, you've got a source. That's the original message, like your voice. Then an input transducer, think of a microphone, converts that into an electrical signal. A transmitter then sends it out through a channel that could be a wire or just the airwaves. And finally, a receiver on the other end catches it. It's a simple process, but it is absolutely universal.
So, sending one message, that seems pretty straightforward. But what happens when it's not just you? What if millions of us are trying to send phone calls, videos, and emails all at the same time through the same channels? Well, you get total chaos.
Yeah, the big problem here is what's called interference. If all those signals just crashed into each other, you'd get nothing but a garbled, useless mess. The solution then is all about organization. It relies on a couple of really ingenious tricks, but let's start with the first one, modulation. Just think of it like traffic control, giving every single message its very own lane on this information superhighway.
To get this, first, just picture a totally empty lane on that highway. This right here is what we call a carrier wave. It's just a clean, predictable, consistent signal. It's not carrying any information at all by itself. It's basically an empty vehicle, just waiting for its cargo.
And this is where that empty wave finally gets loaded up. Our original message, say your voice again, is used to modulate or change the shape of that clean carrier wave. You see how the information from your voice is now literally encoded in the height or the amplitude of the wave? That's modulation. And that's exactly how your message claims its own private lane on the highway. Okay, so we've figured out how to conquer distance and how to handle traffic, but there's another massive enemy we have to deal with: noise. You see, as a signal travels, it gets distorted and corrupted. It's just like that game of whisper down the lane. By the time the message gets to the end of the line, it's completely garbled.
The solution was a total game changer, a complete shift in thinking. And it was captured by this incredible insight. Any message, no matter how complicated, can be sent using just two symbols. A wink of an eye, a flash of light, anything with two states. And you know what those two symbols are, of course, good old ones and zeros. By converting literally everything, a sound, a color, a word, into a string of these binary digits, we create a signal that is unbelievably tough and super resistant to noise. Now this, right here, is the true magic of going digital. Think about it. A faint whisper just gets fainter and fainter, right? But a digital signal is totally unambiguous. It is either a 1 or it's a 0. There's no in between. So at different points along the journey, these little devices called regenerative repeaters can look at a messy, noisy signal and go, that's definitely a 1, and then just fire off a brand new, absolutely perfect 1 to send on its way. The noise gets completely eliminated. Not just reduced, but eliminated. But there was one last massive challenge to solve, and it was a big one for the military. How can lots of users share the same airwaves, not just without interfering with each other, but also securely, so an enemy can't just listen in or worse, jam the whole system? The answer was a brilliant technique called spread spectrum, and more specifically, a method known as frequency hopping. So instead of staying in your one assigned lane, your signal rapidly and unpredictably jumps between tons of different channels. To anyone trying to eavesdrop, it just sounds like a bunch of random noise. And where this idea came from? Well, it's honestly one of the best stories in tech history. This patent for a secret communication system was co-invented during World War II by the glamorous Hollywood actress Hedy Lamarr. No joke. She was inspired by the way player pianos work, and she and a composer friend came up with a system using 88 different frequencies, one for each key on a piano, to guide torpedoes secretly.
It was way too advanced to actually build back then, but that core idea, that frequency hopping, it became the foundation for technologies we now absolutely cannot live without, like GPS, Wi-Fi, and Bluetooth. So here's the really cool part. These aren't just separate, dusty inventions from history. No way. They are a symphony of technologies, all working together right now inside the very devices you use every single day.
Just think about it for a second. That Wi-Fi router you're probably using right now, it's using that spread spectrum idea, that frequency hopping, to avoid interference from all your neighbors' networks. Your phone uses a really advanced version of multiplexing to let you and millions of other people all talk at once. And every single crisp, perfect video you stream, well, that relies on that digital encoding to arrive on your screen without a single error, no matter how far it had to travel.
And that is how we get an entire universe of information onto this little screen in your hand. It's this incredible story of human ingenuity, of solving one massive challenge after another. We've conquered distance, we've beaten noise, we've figured out capacity, and all that leaves you with one really tantalizing question. What's the next great communication barrier for us to break?